Okay, so we're sticking with Nintendo here. They've released a patent. There's an upscaling patent from Nintendo's European Research and Development Wing, actually. And obviously, in the wake of all of the Switch 2 leaks, it is of clear interest. Now, Alex, you've taken a look at this. And I just skimmed the first couple of pages and it looked to me like Nintendo was trying to patent DLSS. Yeah. But it actually turns out that they're trying to patent a lot of different things, and it's a bit of a mishmash, and none of us have really got any idea how this actually got passed as a patent, but please go ahead.
Yeah, so like Rich said, it is the people on the patent as well as the name of the company is Nintendo. It's I think at least three very French sounding names, maybe Swiss sounding names, maybe French speaking Belgian names. I really don't know. Three gentlemen at least working at Nintendo's European office there, and their research applied machine learning as well. A number of them have been working there for quite a while. And the patent does describe, I would say like primarily within the first few pages, it's really obvious that it is describing just via imagery until it gets to later on with the body text. It's describing a machine learn assisted upscale from a lower internal resolution to a higher output resolution. And the very specific called out numbers throughout the entire document, which I'll get to in a second, are 540p to 1080p. And the description is basically breaking up the screen into small tiles, much like a convolutional neural network would do, and then running it locally via inferencing here on some sort of, and they describe actually tensor cores extensively throughout the document. They call them out. They call out CUDA as well too, to do all that process and get a higher image at the end. But this patent is 39 pages long, including the title page there, and it describes actually a lot more than that. If you go through the rest of the other series of images, for example, one of the patents, the embellishments of this patent is that they describe a cloud version of the same thing. They describe also the training process as well too, essentially training on a larger system, which then sends out the inference model out to the various devices, presumably through title updates and or through system updates. They describe a lot. There's a lot more, but some of them are more device specific that I kind of want to get into now. So one of the things that makes this patent different than like standard DLSS is that the pure description of the flow that they show there doesn't actually describe anything with motion vectors or anything like that. And that's actually directly referenced at one point in the patent itself. Let me just call that up. Sorry, I've got it right here. They call them the various kind of like sub versions of the patent, like the little bits in it, that because it's such a encompassing thing, they describe them always as embodiments of the patent. It's a great phrase. And this is referenced, I believe, maybe on page 27. It says, in certain example embodiments, as in certain variations of this patent, the initial image may be rendered or otherwise generated with motion vector information or depth information, e.g. Z-buffer data. This information may be used to improve the resulting converted image quality. Such information may be, in certain example embodiments, added to the activation matrix, which is part of this like flow there, towards the beginning, that is created based on each pixel block. So the patent does describe also a DLSS style, but another thing that it references, that which would be using motion vectors and previous frames as a result of that. But it also does describe a single image being upscaled with a machine learning network to a higher output resolution, e.g. video, e.g. It would also represent things like a kind of dumb upscale that uses machine learning. Oliver referenced earlier, like a bilinear or Lanczos style, simple, somewhat higher quality-ish than just a linear upscale. But this describes, basically, it doesn't need to just be machine learning DLSS style upscaling. It can actually encompass upscaling video content, singular images. It can encompass upscaling textures. It can encompass a whole lot of things. It's an extremely broad patent as a result of that. That's why I'm shocked that it was even allowed to be a patent, because surely there's existing work in this field. But either way, so it does describe DLSS. Another thing that it describes is that it says exclusively throughout the document in each of these figures, for example, 540p internal image being brought up to 1080p at the end, but they exclusively call out explicitly call out that that is just a representation, can represent the fact that the device, the handheld device, will be a lower resolution than the potential connected output device, a la Switch or Switch 2, where the device is lower resolution than the potential output screen that it is attached to. They call out very specifically 720p to 1080p. They also call out 1080p to 1440p. And a whole other variety of things like 480p to 1080p, 1080p to 1440p, 1080p to 4K, and 720p to 4K. So they're kind of trying to cover every single DLSS mode in here. And I can't believe this is all in a patent, by the way. It is very super specific and overly broad at the same time. Okay, another couple of things that they call out that I think are pretty interesting is that, as Oliver talked about earlier, and as we've shown before in the past by looking at, I made a video ages ago, and Rich looked at this too with the 2050, that DLSS itself is really expensive to get up and running in its full desktop quality form on a low power chip. And this patent, at a variety of, in multiple parts of it, too numerous to call out, does actually draw attention to the fact that this is a compute heavy process as well as a bandwidth heavy process, which a low power device using low power RAM chips, DRAM as they describe it, may not be able to do within 1/30th of a second or within 1/60th of a second. They don't use millisecond numbers here. And it calls it out that the network that they're describing here is specifically targeted to doing it within 1/30th or 1/60th of a second on a low power chip. So if it is potentially different than standard DLSS in this aspect, where it might be cheaper, but at another section of the later part of the patent, they describe very specifically one of the embodiments of this patent is that the model, based upon real-time data coming from the game engine, can be switched out in real time or prepared ahead of time programmatically to use a lower quality upscaling model to fit within a certain frame time budget. So they're describing if the game, for example, exceeds, the game engine sends out an image that exceeded 16.6 milliseconds or something like that, or 33.3 milliseconds, this theoretical Switch 2 game device would then use, in this moment, a lower quality upscaling model to get the final 1080p output image, for example. And this is describing not dynamic resolution scaling, but it's describing dynamic deep learned upscaling. I don't know how to describe it. Like the model's being switched out in real time to a lower quality one so that the frame time can be kept up or the frame rate can be kept up, which is wholly new. And I don't think we've seen that anywhere before. I've never seen that described anywhere before. But I thought that was wholly interesting. And it may be an aspect of the Switch 2 that we hadn't really thought about. The fact that depending upon the game and the device and the requirements for the developer, it could be switching out various types of DLSS models, ones that are cheaper than others, and it could even do it potentially, as the patent describes, in real time, depending upon the current frame time, which would be
That's interesting.
Which would be very interesting, actually, and it would be a new novel technology here, very much so exclusive to something like the Switch, because in the desktop environment, this is probably not needed. Probably most definitely isn't not needed for unless you're on like a really low powered laptop. So
Yeah.
but there's even more in the patent here, but a lot of it is it's just really, it covers way too much. It goes over the fact that it describes like cloud upscaling. The device could be, this game device could be in a cloud, and it could be upscaling on the cloud side of things and then sent as a stream to the viewer. They also describe a stream being sent over the cloud to the viewer, which is then upscaled on the local device using machine learning. So another potential Nintendo streaming service description there. It really covers so much about how either in the cloud or on a local device, some sort of machine learning upscaling can occur. The last thing I'm going to say is that they also describe how this process, one of the embodiments, is that a game could have 4K textures. So they say 4K images here. It's a little bit poorly written, I would describe. And it could have like an on-disk size of, let's just say 80 gigs. And they describe that. And then they say, but it could be shipped with 1080p images or textures and then be upscaled in real time by the device to have smaller disk size, 20 gigabytes. So they're even describing like neural decompression almost of images up to a higher resolution one to make game disk sizes smaller. This is such a broad patent. But yeah, to say the least, some of this tech here will definitely be in Switch 2, and this patent was put out December 31st, 2024, just a few days back. So it's very relevant to what's going to be happening in the Switch 2.
Mm-hmm. And equally, though, a lot of it could just be stuff they've been working on that will never make it to a shipping product. I mean, I've spoken to engineers who've got like a wealth of patents that, is just stuff that they worked on that they thought was worth protecting, but they never actually made it into a final shipping product. So it's worth bearing that in mind.
Mm-hmm.
With, big asterisks and caveats and everything else. Do you have any reaction to this, Oliver?
No, just to say that some of these patent filings, I mean, I've read through some of this language here and in other filings, although it is fairly dense. They are a bit ridiculous in terms of how broad they are, in terms of what they cover, because you're really looking for the maximum coverage that the patent office will accept with the minimum specificity that they'll accept rather. And that's a frustrating combination for someone who's just trying to read through one of these documents and identify, like, okay, what are the specific details of this implementation, and how would it be unique, and could someone even look at this and implement something similar with this if they were experts in the field, based on the specificity, questions like that patent offices have to deal with, and sometimes they don't do a great job there. But, I'm kind of reminded of that Mark Cerny patent from earlier this year that had some significance potentially, but ultimately, I'm just inclined to say that this is a bundle of technologies and techniques here that are, maybe they'll show up in a Switch 2, maybe they won't, until we see the actual hardware, until we understand what it's like working with the hardware from developers. I feel like this is basically going to continue to be a black box for us.
Yeah, I think I quite like the idea of the lightweight DLSS version that's being mooted here. I am curious as to why that would be better than simply lowering the base resolution that's going into the neural network, mind you, which is the more traditional way of doing it.
Right.
So, why sort of occupy the GPU creating a higher resolution image if it's just going to get degraded by the upscaler with a more lightweight model? Maybe it will turn out okay. I mean, we've got this classic example of a custom version of FSR2 on the Switch that Hello Games developed for No Man's Sky that actually looks really good. So, maybe it's simply that the quality bar can actually be reduced significantly without any sort of untoward issues on the output. I guess we just have to wait and see on that. I'm really curious to see what's going to be going on there. And similarly, Alex, although you are famously the person on the team that is least interested in Nintendo Switch, I guess this changes up with the inclusion of a version of DLSS, and it may well be the case that the kind of tests that we've had you run on the various upscalers over the years could actually be transplanted over to testing Switch 2.
Yeah, I mean, for example, if it is different, I think we would want to just test and see how different it is. So if we had an example of a game like Death Stranding being ported to the Switch, the fact that it's also on handheld Apple devices, I think is probably going to be there at some point. But we could do easily tests between PC at similar output resolutions and internal resolutions and say, how different is this model than what we have available to us on PC in terms of quality? So that could be a fun video in the future.
Yeah, I think going back to the tests I did on the RTX 2050, which was like massively downclocked to match a potential Switch 2 spec, the cost of DLSS was just kind of rather high. 540p to 1080p was actually eminently doable. But, you know, obviously there's been a lot of talk about, like, you know, 4K Breath of the Wild. It's using DLSS. But, you know, in my tests, the cost of DLSS to scale to 4K was something like 18 milliseconds. And bearing in mind you've got a frame time budget of 16 milliseconds, it's just not viable.
Yeah,
so,
right.
you know, a lighter weight model would have to be significantly lighter if you go for full 4K. But it's actually interesting from the patent there that they very rarely talk about 4K at all. I only saw like one or two mentions throughout the whole thing.
Mm-hmm. Yeah, right.
So yeah, 4K handheld. I think the bottom line is it just needs to look good on a TV screen. It doesn't need to be 4K. It just needs to look decent. That's what we've been saying for a while now. Anyway, I guess we've got some time to wait until we actually see what the upscaling on Switch 2 is going to be like.